Hi guys, this is an extension for number 11. The question says, use the graph of 5x cubed minus 8x squared plus 6x plus 4 equals y below to find all three roots of the function. So this is the graph. So our first step is using Descartes' rule to find how many sign changes there are. So first you write the original equation, and you can see that there are two sign changes, from positive to negative, then back to positive. So that means there are two sign changes. But when you plug in negative x, you'll see that there are only one sign change, because the equation turns out to be negative 5x cubed minus 8x squared minus 6x plus 4. So from negative 5 to positive 4, there is only one sign change. This means that there are two possible solutions. The first one is you can have two positive real root, one negative real root, and 0 complex root. Meanwhile, on the other hand, you can have 0 positive real root, 1 negative real root, and 2 complex roots. How do we tell which case it is? We can look at the graph to determine that. So as you can see, the graph never touches the x-axis, which means that there are no positive real root. Therefore, there are two complex roots and one negative root. And another way to tell that there is only one negative root is by looking at the graph. As you can see, the graph crosses over the x-axis instead of bouncing off, which means that there is a multiplicity of 1 instead of multiplicity of 2. So second step is basically to first find all positive rational roots by factoring out 4 and 5. So below are the positive rational root, which is plus minus 1, plus minus 2, plus minus 4, plus minus 1 over 5, plus minus 2 over 5, plus minus 4 over 5. Since we know that we are looking for a number, a negative root between 1 and 0, we can cancel out 1 and 2 and 4. Which means that we are left with three possible roots: negative 1 over 5, negative 2 over 5, and negative 4 over 5. So first, we can start with negative 4 over 5. So you write down the coefficient of all the terms, which is 5, negative 8, 6, and 4. Then you bring the 5 down and multiply by negative 1 over 5, which gives you negative 1. And negative 8 plus negative 1 is negative 9. Negative 9 times negative 1 over 5 is 9 over 5. 6 plus 9 over 5 is 39 over 5. And 39 over 5 times negative 1 over 5 is negative 39 over 25. And 4 plus negative 39 over 25 is 61 over 25. Since this gives us a remainder, this cannot be a possible rational root. Moving on to the next possible root is negative 2 over 5. So we start off with the same by writing down the coefficient of the terms. Then we bring the 5 down, times by negative 2 over 5 gives us negative 2. Negative 8 plus negative 2 is negative 10. Negative 10 times negative 2 over 5 is positive 4. 6 plus 4 is 10. And 10 times negative 2 over 5 is negative 4. Negative 4 plus negative 4 is 0. So this is a possible root. Since we know that the graph only has one negative root, we know that this is the only real root. And the third step is basically writing out the leftover into an equation. Since it's the original equation starts off with the cubic degree, then you 3 minus 1 is 2, so the resultant is a square function, which gives us 5x squared minus 10x plus 10 is 0. And since we know that we have two complex numbers, we can use the quadratic equation to find the complex root. And basically, we can plug it in, and we will see that the complex roots are 1 plus I or 1 minus I. So the solution is negative 2 over 5, 1 plus I, and 1 minus I.